Okay, first unit back after the break, our first lesson videos, so hopefully these will all go smoothly for us. Our first chapter back is circle geometry, and so hopefully you've already completed the first part of your word wall where you do all the key terms that we already know, like circumference, diameter, radius, all the words we already know and all the things we already know about circles, so that way when for these lessons, you'll be able to move on. So the first thing I want you to do is I would like to add some new terms to your word wall if you haven't added them on already. And so the words that you can see on your page are the words that we are going to add onto your word wall. And I've actually changed. On your printout, you don't have major arc and minor arc. You only have arc, but I want to split it into both because then we're going to be more specific. So looking at our circle, we have the center of the circle, label that with a, sometimes the center is labeled with a C or with an O for origin, so we'll use O for origin since there's going to be a point C on the circle. So I'm going to make my points, and so these endpoints are going to be what I use to draw our different lines. So the first thing we're going to draw onto the circle are chords. And so a chord is any line that starts and ends at the circumference of the circle. So I've drawn two different chord lines, chord line AB and chord line BC. So we have chord AB and we have chord BC. So you can draw a chord anywhere on the circle as long as it starts and ends on the edge of the circle. So it has both its endpoints at the edge of the circle. And so when you're looking at these chords, they actually come together to create an angle. And this angle is what we call an inscribed angle. Oh, I did it the wrong color. Hang on. Let me fix that. It should be green. Okay, and so we have an inscribed angle. And the reason we call it inscribed is the three endpoints are on the edges of the circle. So I meant to say you can either add this into your notes or you can put it directly onto your word wall that you were creating. It's up to you. If you want to do it here and then make a nicer version on your word wall, you can do that as well, as long as it ends up on your word wall. The second type of angle we need to look at is called the central angle, and it's called the central angle because it has one of its endpoints at the center of the circle. Okay, so this is the central angle we're looking at. We could look at the central angle on the outside as well, but for this purpose, we're going to use the inside angle as the central angle. And so these angles start and end on the endpoints of the circle, and the endpoints are actually the arcs. And so we can have a minor arc, which is the smaller arc. Okay, along there. So going from A to B is the minor arc, and it's called the minor arc because it's the smaller one. And then we also have the major arc, which is the larger arc, going around the other directions. And so this arc is A, B, C, because it starts at A, passes through B, and then goes to C. And these two angles, the inscribed angle and the central angle, actually share the same arcs because they start and end at the same spot. This isn't always going to be the case, but sometimes you'll see this, and when you see this, there will be some properties that you need to pay attention for. So hopefully you've added these all onto your drawing and onto your word wall. You will need to memorize these key terms. So our first example says, determine which line segments represent each part of this circle. I would like you to try to do this on your own, freeze the video, and then double check your work with me afterwards. I'm going to do this in stages because if I leave too many things up at once, the colors are going to get confusing. So we have 4 chords going from B to F, going from A to F, going from A to E, and then going from, I wrote the same one twice, going to B to E. Okay, so we list both endpoints to say where the line starts and ends. We did not use the 2 middle ones because hopefully you noticed that A to C and B to C are actually radii lines or radius lines. So they are not considered chords. I'm going to erase these and then I'm going to put up the central angles. Okay, so the next thing we need to look at are the angles. And so the first angle we're going to look at is the central angle, and it goes through the center of the circle. So that means the middle of the angle needs to be at the center of the circle. Okay, so we have angle ACB as our central angle, and then we have 2 inscribed angles, AEB and then again starting at A, AFB. And so I hope that you notice that all of the angles in this case both started and ended at the same place. We actually have a couple other inscribed angles if we wanted to start at another place. So I'm going to erase these. Erase these lines, because hopefully you could have noticed we could have started at F, and so FBE, so angle FBE, and angle FAE. And these are also inscribed angles because they start and end at the same place. They start and end and have all 3 points on the circumference of the circle. But in this case, they would have a different arc, right? They're opening this way, they're skinny angles, so this would be the minor arc, and then this would be the major arc. Okay? So for these 2 angles, we have the arc EF and the major arc EAB. Okay. For the central angle and for the top 2 angles, they have a different arc. I'm going to erase this arc just to kind of make things a bit more clear. So if we're looking at the central angle, and if we're going back to these inscribed angles, they all start and end on, they all start on A and end on B, or start on B and an A. And so the arc that they have, the minor arc is arc AB. So these ones. And then the major arc is the large one going the other direction. And so I want you to think of the arc like the arc is talking about the pizza crust. Okay, and so from A to B you get a smaller pizza crust, so it is the minor arc, and AEFB is more pizza crust, so it's the major arc. Okay, so hopefully that should be nice and straightforward for you. I would like you to do B on your own, and this is one that we can double check together in class tomorrow. Okay, some more lovely key terms. So what this says, our first circle property says that all inscribed angles, so remember inscribed angles have all endpoints on the outside of the circle, subtended to the same arc are congruent. So when we say subtended, we mean like they're open to the same arc, or they share the same arc. They are congruent. And when we say congruent, we mean that they are the same, or that they are equal. Subtended and congruent are two of your key terms that you need to know, but you can't really draw them onto a keyword diagram. So basically what that's saying is if I'm looking at arc KM, I can have two angles, two inscribed angles that start and end at K and M. I can have angle KJM, and I can have angle KLM. And so these angles will be equal. They will have the same value. I hope you notice that there is another arc. So I'll erase this colors. And I would recommend, as you are taking notes for this unit, that you use either pencil crayons or different colored pens to help keep track of things, because you're going to be drawing lots of stuff on top of these black lines, and it's going to be hard to see the pencil. So the other arc that exists is arc JL. Oops. And from arc JL, we have two more inscribed angles. We have angle JKL and angle JML. And so those two angles will also have the same value. And so we're talking about those two measurements would be the same. And KJM, KLM, we're talking about those two inner angles would be the same value or same measurement. So sometimes if angles are the same measure, we would put just a symbol in. So we'll give them different symbols to show that they're different. Okay, so we're going to apply this. So we need to find as many missing angles as possible. So the angle that we know is angle DCB, and this is an inscribed angle. And it has the arc DB. So if I can find any other inscribed angles that have the same arc, they will also be 38 degrees. So starting at D, I see, are there any other lines I can follow? Well, I can go to A, and then I can go back to B. So I've started and ended at the same spot. So that means that angle DCB equals angle DAB. And so they are both 38 degrees. So this angle is also 38 degrees. Okay, moving on to the second one. Angle 25, I can see is an inscribed angle. And this is the minor arc that it's on. So I need to see if there are any other inscribed angles that are on the same arc. So I'm going to start at the same point, follow a different line, and try to end up at the same spot. And we do. So this blue angle is also on the same arc, which means that this angle is also 25 degrees. That's it. Let's look at the third one. 18 degrees is an angle in here. It is an inscribed angle. All 3 points are on the outside of the circle. This is the arc that it has. So I'm going to try to draw another angle that's on the same arc. So I'm going to start at the same place, go up, go down, and I have not ended up at the same arc. This angle has a smaller arc, so I don't know what that angle is. I don't have enough information to figure it out. So just because the lines are close doesn't mean that they necessarily are the same. So watch out for that. Okay, the next circle property says that the measure of a central angle is twice. So 2 times the measure of an inscribed angle subtended by the same arc. So if you have a central angle and an inscribed angle on the same arc, the central angle is going to be double the size of the inscribed. So Our arc is AD. The central angle is ACD. And the inscribed angle is ABD. So angle ABD is, oh, sorry, missed a word. I want to write inscribed first. So what this is saying is that the central is equal to 2 times the inscribed angle. So 2 times angle ABD will give us the central angle, ACD, or if we want to think about it the other way, the inscribed angle is equal to the central angle cut in half. So ABD is equal to the central angle divided by 2. Okay, so that's an important property to keep in mind. So we're going to use that property to find these missing angles. Okay, so central angle and inscribed angle on the same arc. The inscribed angle is 49 degrees. So we want to know what this central angle is. Well, to go from inscribed to central, you need to double it. And if you notice, this is a wider opening than the inscribed angle, so it should be getting bigger. So this angle is going to be 49 degrees times 2. And so our central angle is 78 degrees. That doesn't make sense. That's too small. 98 degrees. How about that? Okay, let's look again. This is the arc we're using. It's a little arc this time. We know the central angle and we want to know the inscribed. So the central is 20 degrees and the inscribed is going to be half of that. And so this is the inscribed and it's a smaller opening. So it's going to be 20 degrees cut in half. So the inscribed angle is 10 degrees. Okay. This is going to be a special case. Look at how happy that one is. Aww. I hope that you notice that we have a diameter line. And so we have a diameter line as our central angle. And then we have an inscribed angle, and they share the same arc. And so this is the arc. The central angle is a straight line, so it is 180 degrees. And so the inscribed angle is going to be half of that. And so the inscribed angle is actually a right angle, or 90 degrees. And so this is another special property. Just write this down below. And so an inscribed angle in a semicircle, or half a circle, is a right angle. So it is a 90-degree angle. Okay, I know this video is long. We're approaching 20 minutes. We'll have at least one period of class time to work on this, but if we're really struggling, we can take another half a class or so. And that is it for your first lesson.